Hi guys, good evening. My name is Amol Gyaneshwar. I am a core committee member of SIAM VIT and today I'm here with Machine Learning Made Simple. For this course, there are no prerequisites except for a very basic knowledge of Python. Today we'll be coding in Jupyter notebooks and syllabus for today is Numpy and Pandas. So here's how it's going to go. I will teach you the basics of numpys and pandas and all of their syntaxes, and then we'll try and attempt an exercise by the end so that you get an hands-on experience on how it goes. So you could pause the video and solve it on your own side by side, or you could stop, save it, and then continue later. You can watch with me and I'll show you the answers for this and you can attempt it later. We will upload the video later on the SIAM official page so you can refer to it for answers. We will share the link for this particular exercise as well. So let's get on with it. Now let's start with numpys. Numpy or Numpy is a linear algebra library for Python. The reason it's so important for data science with Python is that almost all the libraries in the Py data ecosystem rely on Numpy as one of the main building blocks. Numpy is also incredibly fast. It has bindings to C libraries. For more info on why you would want to use arrays instead of lists, you could check out this great post by Stack Overflow post. I'll send in the link below. So today we'll only learn basics of NumPy, and to get started we need to install it. So very few basic installation instructions. It is highly recommended you install Python using Anaconda distribution to make sure all underlying dependencies such as linear algebra libraries all sync up with the use of Conda itself. If you have Anaconda, install NumPy by going to your terminal or command prompt and typing the following: Conda install NumPy. And if you do not have an Anaconda and you cannot install it, you could refer to NumPy's official documentation on its website. So once you're set and that is set up, you could then continue to using NumPy. So let's get started. Now, once you've installed NumPy, let's import it. So to import NumPy, we can simply write import NumPy as np. And one thing I would like to mention for those of you who are using Jupyter notebooks for the first time, to enter a command like we used in Python, in this particular cell we have to press Shift Enter. Now that will automatically execute the command in the previous line and that whole cell will be completed and then it will create a new cell. Now coming to the next part, I'll show you an example. For example, if we do 1 plus 1, enter 2, and we could perform all basic functions here, 4 and so on. So let's say if I wanted to check out the answer and insert another cell in the middle before showing 2 into 2 is 4, I could press Alt Enter and this would give me a cell in the middle. Had I not pressed Alt Enter, we can delete cells by pressing double D. So we press D twice and then it's gone. Had I pressed Shift Enter here, it would have taken me to the next cell. But to add a new cell, over here I would press Alt Enter. So that this is some basic knowledge for Jupyter notebooks if you already don't know. And yeah, okay, let's go back on creating our array. So we had imported numpy as np, and then going ahead. So now numpy has many built-in functions and capabilities. We won't cover them all, but instead we'll focus on some of the most important aspects of numpy, um, which are namely vectors, arrays, matrices, and number generations. So let's start by discussing arrays. So let's get to NumPy arrays. NumPy arrays are the main way we will use NumPy throughout the course. NumPy arrays essentially come in two flavors: vectors and matrices. Vectors are strictly one-day arrays and matrices are 2D. But you should note a matrix can still have only one row and one column. So let's begin with our introduction by exploring how to create a NumPy array. You can create an array by directly converting a list or list of lists. So let's say I create a list, my lists, and we'll give it 1, 2, 3. And we will see how my list looks. So yeah, 1, 2, 3. Now to create the array, this is the syntax. You use numpy, which is np, then array, and then you pass in your list. You can cast a normal Python list into an array, and sorry, my bad, this is my list, sorry. So yes, this is how your array would look. Now you must be wondering, I had mentioned matrices, right? So what about matrices? So let's say I have my matrix, something like this probably. Okay, here. So now you see that we've created a matrix over here, and now we're going to use numpy arrays to show it. Now here we go. np dot array, and then you pass in your matrix. Here. So, okay, one more thing I would like to point out. So if you had to differentiate between a matrix and an array, and a single 1D matrix and 2D matrix, you could just see the number of brackets there are. So if you would notice that here only one bracket is there, so this is one, this is 1D, and over here you notice two sets of brackets. So this is a two-dimensional array. So now going ahead, now let's see, there are built-in methods, there are a lot of built-in ways to generate arrays. So let's look at the first one. The first one is arrange. So let's see how it works. So it's np dot arrange, and then so basically you will have to, I will show you something very interesting. If you press shift tab on your computer, you will get all the basic details and how the function is used. It is a very user-friendly software, Jupyter Notebooks. It will help you out with everything. So basically first you have to put in the value where you would like to start, and this is something very similar to Python's built-in range function. So start value and stop value, and start value is inclusive and stop value is exclusive. So here if I run this, you will see an array from 0 to 9. If I had to include 10, I would probably press 11, and yeah, this gives me 11. Now just like the range function in Python, this could also, you could also give it numbers to break it into leaps. In C++, you write I++, right, in a for loop. So if you write I equal to 2, it will jump by 2. So if you want your array to skip certain numbers or certain variations, you could do that by the following: np.range. So I will shift tab and I'll show you. So step. So you could add your step here. So this is your step function, and so 0, and let's say I put in 11, and let's say I want to skip, I want to get all the even integers in this list, so I'll put 2, and now I'm getting the list of all even numbers in this list. Great. So now you know the basics of this. Now let's get we could also, there are a lot of other built-in methods, for example zeros and ones. So you could create zeros and ones by np.0 and np.0 here, and number of elements you would want in the list, basically the number of zeros that you would want. So let's say I want 5 zeros, an array consisting of 5 zeros, and oh my god, I'm sorry, zeros, that's typing error. Okay, so this gives me an array of 5 zeros. Similarly, you could do the same for ones as well. So there is the same thing for ones, np dot ones, and let's say this time I want 3 ones. So I get 3 ones. This is very simple, very basic. And now there is this function called linspace, Linspace. This returns evenly spaced numbers over a specified interval. So let's say np dot linspace, and between 0 to 10 I need 3 equally divided numbers. So they should show us 0, 5 and 10. So 0 to 5 same distance, 5 to 10 same distance. So there are three numbers which have been outputted here. So now let's try with a bigger set of data. Let's say a, or larger number of Linspace. So npa dot linspace, and okay, I could also show you by shift tab. If you press shift tab, you could see its properties over here, and then you press this plus button. So start, stop, num, endpoint, this all of this you could use. So over here, let's say I want my starting point to be 0, then I want to take 10, and I want 50 numbers in the middle. So if I run this, you would get something like this. Now if we had to create an identity matrix, NumPy already has a built-in function called I. So if I create np.I, and for a matrix, identity matrix will always be same number of rows and columns. So you don't have to insert a tuple with the values of the two different values of rows and columns. You could just put in one value. Let's say I want a 3 by 3 identity matrix, and this will give me a 3 by 3 identity matrix. I want a 5 by 5 identity matrix. I'll get a 5 by 5 identity matrix. Okay, NumPy. Now something very interesting about NumPy is the number of random variable, the way it creates random numbers, and the way it inputs random numbers into arrays. There are a lot of ways to do this. So let's start with rand. So we'll start by calling np.random. This is the way you create a random number array. So if we use rand is basically used to create an array of the given shape and populate it with random samples from a uniform distribution over 0 to 1. So it is, I will repeat, it is used to create an array of the given shape and populate it with random samples from a uniform distribution over 0 to 1. So over here I could, let's say, put in two values. I wanted two values. So this is 0.5 is between 0 and 1, and so is 2. I say, let's say I want a 3 by 3 matrix, and then this shape, it'll give me a shape of this. So, and now let's move on to the next function. We have rand n. Similarly, to input a random number, it now rand n returns a sample or samples from the standard normal distribution, unlike rand, which is uniform. So I will repeat, rand n returns a sample or samples from the standard normal distribution, unlike rand, which is uniform. So if I had to do that, it'll be np.random, and I'll call rand n, and then over here I'll say, let's say 2. And you get the idea. And then if I want, let's say, a 2 by 2 matrix, and over here it goes from 0 to 1, sorry, -1 to 1. So this is different from rand and rand n. Now let's come to the third part. Let's say you want a random integer from one particular number to another particular number. In this, the lower part will be inclusive and the higher part will be exclusive. So how to do that? np.random .randint. This is what is used to get a random number between two numbers, lower inclusive, higher exclusive. So let's say I want one random number between 1 and 100. So let's see, I get 66. Now if I want, I'll copy paste the same instruction here. And now let's say I want 10 random numbers between 1 to 100. I'll go ahead with this. So this will give me an array with 10 different numbers. Don't worry if you try this and get different numbers. Will give you random numbers. So it will definitely not be the same. Okay, so let's discuss some useful array attributes and methods on an array. So let's say I create an array, and I make it np.range, and I keep it up till 25. So this will basically be up till 25 or up to 24, 0 to 24, all the numbers in array. Space it out for better. Yeah, okay. And now we'll create a new random array equal np dot in random rand int from 250, and let's say I want 10 numbers in it. Okay, so I'll be creating these two arrays. This is one is random and one we know is 0 to 25. And okay, so let's run that. Okay, I forgot. Sorry. Okay, so now let's see what array looks like. So ARR will look like 0 to 24, and then let's see what our random array will look like. RA and ARR. This will look like this. Okay. So now let's see something. So now if you want to reshape your array, let's say you had a scalar array and you want to convert it into a 2D matrix. So if I wanted to reshape, see this is now how do you figure out? I told you you look at the number of brackets in this. Now number of brackets is 1. So this is 1D. Now you have to reshape it to a 2D array. So then the number of elements is 25. So it could be the multiples of 25, right? 5 is 25. So we could create, we could reshape to it to a 2D array, 5 into 5 array. So 5 reshape, and then 5, and then now let's see. So now that gives us a 2D array with 0 to 24. So if you see clearly, you'd see different number of brackets. Earlier over here we just had one set of brackets, everything was inside one bracket, but now there are 5 different brackets containing 5 different values. So this shows that this is a 2D array, not one. Okay, now let's discuss a few maximum, minimum, and how to find the maximum and the minimum. So let's say we have, you remember R NAR, and yeah. So now if in this, if I had to find the value which is maximum, so if I could just call it by calling max. This gives me the maximum value 49. As you can see over here, 49 is actually the highest value, and for minimum value it would be a min, and minimum value is 1, which is correct. Now if you want to know the index position of this of 1, so you could just write argmin, and that gives you, see, index position starts from 0, so 0, at 0 we have 48, at 1 we have 3, and at 2 we have 1. So minimum value was 1, and the location or index of that value was, similarly we could do it for max. So 4, so 0, 1, 2, 3, 4 gives us 49, which is exactly the answer. So you have now understood min and max. So okay, now let's come to shape. Shape is an attribute that arrays have. It is not a method. So let's see what's the shape of our earlier array. You remember ARR, right? ARR. So if you had to check what shape this array has, so you could just do array.shape. Sorry, my bad. Those parentheses are not required. Okay, 25. So it's a 1D array containing 25 numbers. Now we've already discussed reshape, so we'll not go over that again. And so you could also figure out the data type in your array. So to figure out your data type, all you would need to do is array.data type. Sorry, D type, my bad. I'm so sorry. So as you can see, it's an integer type array, and yeah, this is it. So we have now completed the basics of arrays in Numpy. Now let's move on to indexing and selection of Numpy. So you remember array, how to create an array. Now let's create an array and change it. Array, now we'll keep array equal to, let's say, from 0 to 10. So if we had to keep it from 0 to 10, 0, 11, I've kept it as 11 because 11 is exclusive. So we run that and I'll show array. So now array is 0 to 10. So simplest, okay, so now indexing and let's come to indexing and selection. The simplest way to pick one or more elements from an array looks very similar to Python lists. So to get a value from the array, you could just type, let's say you wanted the 8th value. So you could press in 8, you'll get 8. If, okay, so you know about slicing, the way it is done in Python, it is exactly similar in Numpy. So if I had to get 1 to 5, 1 not inclusive, sorry, 5 not exclusive, 5 is exclusive, so 1 2 3 4. So simplest way is 1 minus 5, 4. So 4 numbers will be there. So 1 2 3 4, and it beginning from 1 is always inclusive. And so let's move on. You could also give this value to another array. So let's say, let's call something like array equal to this, and let's run that. And if you output r, it will show 1 2 3 4. Voila. Okay, now this is done. So now if you had to change the slice of array, you could probably do this. This is a smarter way of calling all the numbers in an array, and we're setting them to, let's say, 99, and we run it. And if we now call r, it'll look like this. It's a bunch of 99s, which are 4 99s which are there. And now if we see r, there's a change in this too. Data is not copied, and it's a view of the original array. This avoids memory problems. To get a copy, you need to be explicit. So you need to type array. If let's say you want to make a copy, arr copy equal to arr dot copy, and we look at arr copy. My bad. So it looks like that. Okay, now let's see indexing in a 2D array. So let's have a 2D array. Let's see if I have an example of a 2D array already. No, I do not have an example of a 2D array. Okay, never mind. So let's create a 2D array over here real quick. So let's create add 2D, and we'll say np dot array, and let's say we'll give it our own set. First set, we let's say give 5, 10, 15. Next one we give 20, 25, 30, and next one we give, let's say, 30, 40, 45. Now let's see how array 2D looks like. Okay, so now if we had to now indexing rows. So now if we had to index a row, all you have to do is just call out the index value for that particular row, and you'll get all the values. So let's say I have an add 2D, and I say I want to see the second line. So I could just input 1, because index value 1 will show me the first. So this is 0, this is 1, this is 2. This will give me this. This is how you select a row. If you want to select a particular number, let's say you want to get 25. So here, basic matrix types, you have to find the index value 1, 1, So if I run that, you'll get 25. This is all about indexing. So let's keep it to a very basic indexing. And now if we had to go over selection, this is how you would go for selection. If let's say okay, now I have my array. Uh, we'll recreate the array for simplicity. Np dot range, and we keep it, let's say, from 1 to 11, and we see how our array looks. It looks like that. Now we want to see all the numbers that are greater than 4. So now greater than 4. Now this will give us a false, false, true, true value, boolean values. And now to actually see just the numbers which actually have these values, we could pass the same thing inside the array, and this will give out just the values of those numbers. So this is one way to do that. And yeah, we're done with NumPy indexing and selection. Good job. And now we could now let's move on to NumPy operations. So now we have the same array. We'll continue with the same array, and we have up till 10. Great. So now you could perform basic operations like addition, and you'll get the same thing. You could do subtraction. You could do multiplication. Here. So this gives you multiplication. You could perform all basic operations. Now something interesting about NumPy is that if you divide any number by 0, it should give you an error. But like here, division by 0, which is pretty basic. But now if you do that in NumPy, NumPy has a variation for this. So let's say if I divide r by r, technically my first number is 0, and uh, it should give me an, oh sorry, I will change my array. Over here I'll change the array to something different. Let's say if I change my array to, let's say, np dot range from 0 to 10. Alright, and now if we do r divided by r, you'll notice that NumPy gives us a nan value. Now this nan value would basically tell us that something is wrong, that 0 divided by 0 doesn't make sense, and it's not a valid function. So see, if I do 0 by 0 over here, it'll show me an error, but in NumPy it's not the case. It'll the command will run, but it will show a nan operation. So this is about it, and with this we're done with basic operations. In array you could also do other operations. You could use the website, but I'll show you one or two more. Let's say np dot square root of the array, and you just have to pass the array inside the brackets, and you'll see the square roots. Now if you want to see the maximum value of the array, which I've already shown, if you want to see the sign value, it will be np dot sign, then you pass in the value of your array, then np dot, if you want to find the logarithmic values, then you pass in the array again and run this. So you notice infinity, because at 0 it'll tend to infinity, so that is also correct. And now we are done with NumPy. So this was the basics into NumPy. Now let's move on to our next topic, which is Pandas. So in Pandas we're going to have an introduction to Pandas, series, then data frames, missing data, group by, merging, joining and concatenating, operations, data input and output. So let's start. So series, the first main data type we will learn about for Pandas is the series data type. So let's import a Pandas and explore the series object. over here, import pandas as PD. All right. Now, I had already saved a list. From here, I'll copy paste this. I'm doing this to save time. So, okay. So now creating a series, you can convert a list, numpy array or dictionary to a series. So first let's see by using lists. Now over here you'll see if I run this. Okay. So if this is the syntax for that, pd dot series, and I input, let's say, data as my. So as you can see, you will get index value 0, 1, 2 with the data. Now you could do the same and put labels. Let's say you want to put ABC as instead of the index. So what you would do is, I'll copy paste the same command. It's the same command. And now you'll add a index value and labels. So now you see ABC has been replaced by has replaced 0, 1, 2, and you could actually just remove this index and it will still run. I'm sorry that if it, okay, index value. So now index is taken up by this, and yeah, okay. So now let's move on to array. Let's say we have a numpy array, and numpy array, if we had to create from a numpy array, if we had to create a series, it's very simple. You would do pd dot series array. You'd input the array and then labels. See, okay, so last time what I was trying to do was instead of writing index equal to, you could actually not write it, and it could directly, it will understand that the next value you're inputting is the label is the index. So array is your 10, 20, 30, and this is how you do it for a numpy array. Now the simplest is if you make a series out of a dictionary, it already has values corresponding to its keys, right? So very simple. I'm going to start this again. Sorry, pd dot series, and then I would just have to input the dictionary into this, and voila, you get it. So now uh, let's understand how to using an index in keys. The key to using a series is understanding its index. Pandas make use of these index names or numbers by allowing for a fast lookups of information. Works like a hash table or dictionary. Let's see examples of how to grab information from a series. Let's create two series, series 1 and series 2. So wait, I would already be okay, I don't have it. Let's create our own. Let's create a series 1. So let's create series 1 and we'll call it pd dot series, and first I'll put in 1, 2, 3, 4. Then my index will be, let's say we take countries, we take USA, we take Germany, we take Russia, and then let's take one more country, let's say Japan. Okay, Now let's see how our series 1 looks like. So there you go. And this is done. Let's create another series. But this time what we'll do, I'll copy paste everything from here. We'll make small changes in this series. So we'll call it series 2 pd.series, and then I'm going to change these values. Let's say I'll put it to 1 2 5 4, and then in the countries, let's say I change Russia to, let's say, India, and then I run it. Then let's see how our series 2 looks like. There you go. Okay, so if I wanted to see the value for, let's say, USA in the first series, I would just do CR1, and then I would check to find USA. I would do USA directly, and that will show me the index value for that there. So that is done. Now this is how you would do that. You could perform basic operations like series 1 plus series 2. Now you see there are two nan values. These nan values are because it tries to matches the index, but index is not matching. Sorry, yeah, index it's not matching, and that's why it won't be possible. So for there'll be two values for nan. Let's say in that those must be India and there must be Russia, because they aren't here. So it's 5 Germany, Japan 3, and then USA 9. So you can also add and see for yourself. So this is for series. Now let's come to data frames. Data frames are extremely important. So let's start with a data frame. Okay. Data frames are the workhorse of Pandas and are directly inspired by our programming language. We can think of data frames as a bunch of series objects put together to share the same index. Let's use Pandas to explore this topic. So we could so for this, first from Numpy, if you remember from Numpy, we'll just import a random numpy dot random, then import randn from that, and then np dot random dot seed. Now the reason why I'm doing this is because so that you guys get the same random values as me, because otherwise you would get different values. Whatever you do is not wrong, but it would be different from what I have. So let's see how to create a data frame. Df equal to pd dot data frame, and you'd have to send in your values first. So rand n, let's say a 5 by 4 matrix of random values, and then as your index you could have, let's say, you could keep it as A, B, C, D, E. Now I'll use this tool called split, and that'll give me different headers for each index value. So split, and then columns. So for columns, we can let's keep it as W, X, Y, Z. And now we can do the same thing, split. And now, okay, there's some error. okay. Ah, please close the brackets at the end. I was wondering what's the error. It's a very stupid error. Okay, so now let's see how a data frame looks. We check df. This is how a data frame looks. You'll get something similar if you have inputted np.random.seed. It's give you the same random values as me. And then let's go ahead for selection and indexing. Okay, let's say you want to grab the wth column over here, this column and all the values under this. So it's very simple. You just have to pass the column name and here w if you input w, and here you'll get all the values. Similarly, if you wanted a list of column names, then you could do, let's say, df, and you wanted to see different values of, let's say, w, and let's say x. Sorry, you'll have to change it. You'll have to pass it as a tuple. I'm so sorry, I didn't. To pass them as a list. Sorry. And now it should work. Oh, my bad. This should have been a capital Z. I'm committing so many mistakes. Anyway, so you have to pass a list of column names. A list. So if you want to get a list of column names, you'll have to pass them as a list. This should work. I'm so sorry, it got stuck up for so long. And yeah, so now you have lists. And there is another way you could do this. If let's say you want df dot w, this would also give you your wth column, but this is not recommended because there are a lot of functions with df, which if I press shift tab, you'll see that there are a lot of things that could happen. So yeah, you should not I would not suggest that you go use this method. And now let's say if you want to create a new column, we'll call it, what should we call it? We'll call it new. And so basically, to add a new column, and let's say we want to add df, add the w value and the z values, df, the y values, let's say. Now you've added the new column. Now let's see what df looks like. So this is how df looks like. And now let's go ahead and drop a column. Similarly, you can drop it with this command drop, and then you put in the value of whatever column you want to drop. So let's say w, or new, what we've just created. See, this would show an error because over here axis is set to 0. So now 0th axis is actually giving you rows, not columns. So you would have to make a change and call it axis equals 0. Now it will remove the new column. Let's change it to E. Sorry, yeah, this is how it will remove the E column, a new column. Now you could select rows by this method also, df dot loc, and then you pass in A. This is how you would select your row, or you could select based off their position or index. So this is loc method. This is, now I'll show you index method also, iloc and 2. So this would also show you the same thing. So over here, as you can see, this is the second one. So C, so 2.0186 and then 0.74 and then so on. So yeah, you get the idea. So now let's go to conditional selection. So now let's see, we want values of df which are greater than 0. So this will give us a bunch of true false values. Now to see which values are actually which follow this, you could pass the same thing in this df greater than 0, you run it, where all the values that it doesn't happen will just show nan, which basically means that those values aren't there. And there are other conditions also you can add. For adding conditions here, basic thing you need to know is that you need to put an and in the middle. So if this is one condition, in Python you used to write and, but over here we cannot write and. This will be the ampersand symbol. So or if you have to write or, it will not be or, it will be the pipe. So this way. So this is this is all about and or. Now I could show you, I'll show one quick example. Let's say and I want to show where df, I want to see where df dot w, let's say values of w are greater than 0, and we'll say df, let's say okay, let's say that y greater than 1. We'll cover them with brackets. So now you can see the values which adhere to this. And yeah, this is about that. And this is all about your basic selections. Now we could go, we could get into multi-level, multi-index and index hierarchy, but I think we should discuss that. We'll discuss that next time probably. So yeah, this is about this. I could actually show you in. I'll copy paste this from here to save time, and we'll see. So I just wanted to show you how a multi-level in index looks like. So we'll say df is equal to pd dot data frame, then we'll call np dot random dot rand n between 6 and 2, sorry, not between 6 and 2, matrix of 6 and 2, where index values are, index is equal to r higher index and columns, let's say we'll call columns A and B. Now let's see what our DF looks like. So this is a multi-level hierarchy, multi-index and index hierarchy can be shown here. G1, in G1 there are 2, 1, 2, 3, 1, 2, 3. So there is selection works in a similar way for this also, but this is something a little advanced. We'll probably show you next time. So now let's get into something more interesting known as missing data. Now in missing data, this is a very important thing in machine learning, because you would want to clean and get rid of this data. And so let me teach you basics about missing data. Now wait, now we'll create a data frame. I have a pre-written data frame over here. So we'll run this data frame and then we'll see this data frame. You'll see that there are a lot of nan values. Basically we have where there are no values taking place, and what we could do is we could just say df dot drop na. Basically this would drop all values where there is nan. This is what it would look like. Now if you put drop.na and we put access equal to 1, then you'll get the C column. The only C column doesn't have any null value, so this is what will happen here. And now you could fill in the nan values with df.fill. So let's say, and I want to say fill na, and I want to say value equal, let's say value, what do you want to keep the value? We'll keep the value as, let's say, give the value as 1 2 3. Now you will see that 1 2 3 has replaced all the nans. So this is all about missing data. Now something very interesting, we could do group by. Now this is how you would uh, classify data. So now I already have a pre-written data set. So I've created a data frame from here, and okay, so now let's change our data frame. df is equal to pd, sorry, my bad. So now we can change it to df is equal to pd dot data frames and then we could put it in as data. Sorry. Now let's see df. So this is how our df looks like. Okay. So if you've done SQL before, this will seem very familiar to you. So you could group by let's say you want to see the company, and so for that df dot group by. Okay, you could save this as a new variable and then call aggregate methods of the object. So basically, if I had to describe group by method allows you to group rows of data together and call aggregate function. So if now group by, we've done group by company, so let's call, let's call it by comp. Let's see. Now we could calculate the mean. So by comp dot mean. There you go. Now that gives us the mean of each company and the sales of their mean of the sales. So now this is that. You could calculate the standard deviation. Over here, if I do std, this is the standard deviation. Now if I had to find the minimum sales in this particular data frame, then this would give me in Facebook, Carl had sales of 243, Charlie at 120, Amy 124. And if I had to find the max, now Sarah has 350, Sam has 200, Vanessa has 340. And now if I had to see, if I had to count the number of people in sales, we could actually see from here also. So in Google there are 2 people, Microsoft there are 2 people, in Facebook there are 2 people. So if I had to count the number of people, so I could just give in a simple command called count, and count. There you go. Now there is this very interesting feature in Pandas known as describe. this will give you the basic details of the entire uh, the entire data frame, and then everything is in one place. And you could probably just, if you want to look for just one company, you could, if you want to see it in a different way, you could transpose it just like in a matrix, and here you go. So now it's in a different format. Wonderful. Now let's say if you want to just see it for Google, you could, or FB or anything, you could just say GOOG, and now it's here just for Google. So great. So now we're done with group by as well. Now let's move on to merging, joining, and concatenating. So for that, I have already saved three data frames. Let me copy paste them quickly. And yeah, okay, so now we have three data frames. Now let's look at each one of them. So df1, this is how df1 looks. Now we go to df2, this is how df2 looks. And df3, this is how df3 looks. Great. Okay, so now we know. Now let's concatenate. If you want to put all of them together, pd.concatenate. So a very simple function, and then you add in everything which you want to concatenate. Let's say if you want, you have to pass them as a list. So let's see, we have df1 and df2. So this concatenates df1 and df2. If you want to add 3 to it, you could do that as well. df3, and now all of them are there. Great, wonderful. So, and this is that. We're done with this. Now let's go ahead and merge. So I have two data frames, saved data frames, left and right. Let me copy them quickly. Okay, yeah. Great. Okay, so now we're done with that. So let's say we want to merge pd dot merge, then left and right, and then if you want to do it on a particular key, you could choose that as well. Let's say on key 1. So you could put in key 1. And then key 2. There you go. That's the merged data frame. And yeah, okay, so this is it, this merging and joining. So we're done with that, and now let's move on to the next part. Operations. You could perform the same operations. There are some certain unique operations. So wait, let me copy a new data frame for you guys. So here, let me copy paste this. Okay, so this is my data frame, and I've called data frame.head. This basically shows me the header of each data frame. And yeah, so now I could call all the unique values inside of let's say column 2. So now we know that 44 comes twice, but let's say we want just unique values, so I would just call df call 2, and then I would say dot unique, and then that's it. It'll give me all the values which are unique. And let's say I want the number of unique values, so I'll just add a little n behind this. Give me three unique values. And if I want to count the number of values for each value. So let's say 4 comes twice, 44 and 44 comes twice, right? So if you want to see that see that value twice, so value counts. Now this will show you how many times each value occurs. It's 44 and 44 twice, 555, 1, 6, 6, 6, 1. So yeah, this is these are certain operations you could do, and you could also apply functions on these data frames in a similar way. And now, if let's say you want to come in, how to read an input and output from a CSV file. So you could do that very simply. There are 3-4 formats. It's a CSV input, Excel, HTML, and yeah, that's about it. So okay, let's see. If you had to read a CSV file, basic syntax would be df.pd.read and then CSV. df.pd.read.csv and then example. I have an example saved in my Jupyter notebooks. Let's see how df looks. Okay, example is not saved. So, but anyway, I'll save example again, then I'll show you. So, whatever is the name of your CSV file would come here, and that's how it would go. So, for now, we'll skip this, and this is for just your information. And now we could read a Excel sheet by pd.read underscore Excel and Excel sample Excel. Whatever is your name.xls, and then you will get that input. So that's about that. And yeah, this is how you get your input and output. Now let's quickly go over this simple activity I have planned for you guys. This is a simple exercise which I have for you guys, and I wanted to try it out with you guys, so you can now go ahead and try it with me at the same time. So it's a very simple exercise. It'll hardly take us any time to complete this. So first step is, it says import pandas as PD. So now we're going to import, import pandas as PD, and then okay, now salaries, this is going to read salaries. Now we'll check, we'll delete this. It's an extra created by extra. So now we'll create our header file to see what's there. Check head of the file, this gives us the head. Use .info, so we could use .info, sal.info, and this will give us the info. What is the average base pay? So the average base pay over here is sal, and you put in base pay. And you find the mean of it. That gives you the value. What is the highest amount of overtime paid? So you want to find the maximum value of overtime. And we put in max. Sorry. Yeah. So now, what is the job title of Joseph Driscoll? Okay, so Joseph Driscoll, must be multiple Joseph Driscoll, so you have to be, it's very case sensitive. It's a case sensitive language, so you have to be careful of your capital letters and your small letters. So let's go with that. Sal, and then Sal, employee name. We just have to compare employee name. If my employee name is equal to Joseph Driscoll, then you have to find out its job title. See, so okay, over here, Captain Fire Suppression. So, and you can see that it called out your employee, and it's there. Okay, so now let's go over the last three questions. How much does Joseph Driscoll make? So, how much is to check that how much Joseph Driscoll makes? What do you have to do? Any guesses? You basically have to check his total pay benefits. So I'll copy paste whatever I had written earlier. Same thing would come here. And instead of job title, I'll write his total benefits pay. So there you go. So that's the total amount of total pay benefits he's getting. He makes that much. What is the highest? Who's the highest paid person? So we'll go with Sal. Then we have to check total pay benefits. Equal Sal total, basically the person who has the maximum total pay benefits. You could copy paste this. It's very simple. And then you call in the max function. And then you close the brackets. There you go. These are the details of the employee. Employee name Nathaniel Ford. Base pay is 167,411.18. Lowest paid person over here would be similar thing with just min in it. If you wanted to choose that, if you could actually directly copy paste this. Min. Okay, so it's Joe Lopez. So if you notice something very strange says, it mentions, did you notice anything strange? Yes, it goes in negative. The she's paying salaries. What is the mean base pay? So this is very simple. What you'll have to do is, so you'll have to sal and then group by, and then you'll have to pass in the year. And we'll have to find the mean. And you want the value of the base pay. Alright. So this gives you the answer for that. Now you wanted the number of unique job titles. So let's go sal. This is a very simple function I told you about, n unique, and that's about it. So job title and dot n unique. There you go. So there are 2159 job titles which are unique. All right. So now what are the top 5 most common jobs? So obviously this could be, you just have to count the total and you'll have to, the top 5 you'll have to print out. So here you could copy paste this, you remove when unique, you have to put value counts. Then you put in the head, and this is the top 5. So I'm going to leave a few questions for you guys to attempt. So I'm leaving these 3 questions for all of you to attempt, and then you can tell me the answers for this in the comment section. So this is it for today. This is our first webinar in the Machine Learning Made Simple webinar series. Hope you had fun. Looking forward to seeing you next time. This is Amog Yaneshwar. Goodbye.